Swayam Prabha. Digital India. Educated India.
Next, I want to look at what a gradient of a motion field is or deformation field is. We said that we can write small x as some function of psi x comma t, right. Now, gradient of this is motion or deformation field, as we saw when we looked at displacements. Gradient of deformation field is called as deformation gradient, and is denoted by the symbol f. F is grad of x, this would be dou x by dou cap x, dou x dou cap y, dou x dou cap z, dou y by dou cap x, dou y by dou cap y, dou y dou cap z, dou small z by dou x, dou small z by dou y, dou small z by dou z, where x comma y comma z are the Cartesian coordinates of the material particle in the reference configuration and small x, y and z are the Cartesian coordinates of the material particle in the current configuration. Okay. So, here again this is three functions involving three variables. The three functions are small x, small y, small z as a function of capital X, capital Y and capital Z. Okay. So, here again you should have 9 slopes. The 9 slopes are represented as in terms of a matrix as a deformation gradient matrix, which is here. The 9 components of F is represented as a deformation gradient matrix, which is this. Okay. Now, let us define displacement gradient. Which is denoted by capital H, which is gradient of u. Here I use capital G to denote that the gradient is with respect to capital X, capital Y, capital Z. If it is the gradient with respect to small x, small y, small z, I will use a small g here instead of grad. Okay. Now, there is a difference between the deformation gradient and the displacement gradient. Deformation gradient is on the position vector of the particles, while displacement gradient is on the displacement of the particles. Hence, the expression for the deformation gradient in cylindrical polar coordinates will be different from the expression for the displacement gradient in cylindrical polar coordinates, they are not the same. Okay. So, you have to be careful which gradient you are talking about and what is the expression that is used to compute a gradient. Deformation gradient has a different expression for a gradient, displacement gradient has a different expression for a gradient. Even though both are called as gradients, they are different gradients. Okay. Okay. So, you have to use the appropriate formulae for the gradient when it is a general vector versus a position vector.